The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. On the Ben Heck Show, we use a lot of connectors to build our projects and put everything together. In today's episode, we're going to honor the connectors and talk about all the different types, how to use them, how to identify them, how the pin numbering works, pros, cons, best places to use them, and then show examples for each connector as to how to use it in projects. Let's get started.
Amazing hacks.
How can we make this portable?
Inspired designs.
I am the internet troll.
Regrettable acting.
Batten down the hatches!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
We've laid out a museum quality display of many different types of connectors, and we're going to talk about each of these connectors and how they pertain to projects we've done on the show or projects that you might want to do yourself. Shall we get started?
Yeah.
All right. You recognize this guy, right?
Yeah, you're always taking those off the Raspberry Pi.
The Composite video, which I believe they've finally removed from the Raspberry Pi. So it's called Composite because it composites many different signals together, specifically luminance, chrominance, but not audio, because that would be in a broadcast. But these are still useful to have around. There's still a lot of things that use composite video connectors. And yeah, this was just a through-hole connector. So that means the pins go through holes on the PCB. And yes, this was definitely removed from the Pi. So even if you don't need the connector in a project, remove it, put it in a bin. Eventually you'll need it, because if you throw it away, then you'll need it. Okay, the next connector is S-Video. The difference between S-Video and composite is it separates the luminance and chrominance, or the brightness and the color. And you get a much cleaner picture than you do with composite. Composite has this thing called NTST dot crawl, where you'll see like dots kind of crawl at the edges of things. And it's because composite video is fairly crappy because it's all compressed. And also, in America, our composite video signal is meant to be backwards compatible with black and white televisions. So if you put a color signal or a color broadcast into a black and white television, the black and white television doesn't know the difference. So by hiding the color in the signal, it also kind of produces a not so great color signal. Other formats like PAL and CCAM had much better color in their broadcasts. And I'm talking in the old days before HDTV. Here's VGA. Now this is a DSub 15 connector, which we'll talk about later. VGA is obviously a lot better. The computers started using this in the 1980s. It has red, green, blue, so it has the three primary colors. And there's also H-Sync and V-Sync, so it knows when the line and the frame has changed. But another thing not everyone realizes is that the VGA connector also has an I2C bus on it. You know how you plug in your monitor and then your computer will say, oh, you've got a Dell blah, blah, blah monitor.
Yeah.
That's how it knows.
So that's pretty cool.
Yeah, every VGA port or HDMI port actually has an I2C bus on it, and it cues data from your monitor, which also means you can hack a VGA port. If you're not using a VGA port, you can hack it into an I2C bus master controller.
Huh.
Yeah. One more thing to say about this connector, see how the pins are like little cups coming out the back?
Yeah.
So this is meant to be put into a panel, or it'll be called panel mount when you're ordering things. So you stick it into a panel, you put some screws through it, and then you attach wires to it in the little cups. Versus something like this DVI connector, the pins come out and down at a right angle. So they're through-hole pins at a right angle, so this would sit like this in the PCB and allow you to plug in. So DVI is purely digital, it uses differential signaling, but it also still has backwards compatibility for VGA. That's what this little plug over on the side is. Well, this one doesn't have it, but if there was one, it's red, green, blue ground, I think. And just like VGA, there are two pins in the DVI, which are your I2C bus for device identification.
Well, that's nice.
Yeah. Okay, let's go up the evolutionary ladder a little bit more here. HDMI, this is what's on everything now, right? These connectors are kind of tough to work with. They're always surface mount, almost always at a right angle. Sometimes you'll see one like this. You can usually remove them non-destructively, but putting them back on there can be a pain. So this is kind of getting beyond hobbyist or casual removal or usage. And HDMI, I don't know if you know this, Felix, but it's basically just DVI. In fact, they're completely compatible. HDMI just encodes audio with the stream as well. and it still has the 2 pins, clock and data, just like VGA and DVI before it for device identification. Of course, there's a newer connector laying around that we don't have, DisplayPort. DisplayPort is, again, like an evolution of HDMI, but it has more versatility. You can actually daisy chain monitors together, so you can have one DisplayPort coming out of your computer going into one monitor, and then you can daisy chain that monitor into another monitor. Also, the other fun fact is DisplayPort is open source, so companies don't have to pay the licensing fee to use it that they do with HDMI.
That's cool.
That's one of the reasons it's catching on. Remember these connectors, Felix?
Yeah, you had me wire up a bunch of these for Super Space Shuttle.
Yeah, there were quite a few using that, but they were useful because they allowed us to troubleshoot. Like, if I was like, hey Felix, could you fix this on the board? We could just unplug everything, and then I could give you the board instead of like lugging the whole thing over.
Yeah, it was really great being able to take components out.
Yeah, connectors take more time to install than just soldering directly, but they'll save you time later on. So the Molex Style connectors, you basically have headers and receptacles, and the headers go into the receptacles. Now, if you look these up online, they'll be called wire-to-board connectors because wires go into the receptacles and the headers go into the boards. So you're basically connecting wires to boards, just like on our pinball project. Yeah, so I usually keep a bunch of these in stock. I'll usually have 4-way, 2-way, 3-way, and you also have to buy the terminals separately. So if you buy these online, you need the header, the receptacle, and the terminals that fit into the receptacles. And you also want to watch out that you find individual headers. Usually in mass quantities would be on a reel, and the machine will like just stamp them out and put them in. But if you're doing this, by hand, you want to make sure you find the individual connectors that are already pre-cut for you. When working with connectors, one of the most important things is the pitch. Pitch refers to the distance between the center of 2 pins. Not the distance between the pins, the distance between their centers. So here we have basically 2 sizes, both in millimeters, 3.96 millimeter and 2.54 millimeter. 2.54 millimeter is also 0.1 inch, like the standard spacing for most PCB boards and integrated circuits. The difference, basically density of your connector, and also you can carry more current through a larger pitch connector. Let's look at an example of how to wire these up. Wire to board connectors. So I'm going to do the receptacle first, which is what actually has the wires in it. And I'll just strip 4 wires here. I braid the wire so there aren't any loose strands. Then we set it into the pin and we crimp it. And I like to add a little bit of solder as well, just to make sure that it's in there. It's not a big deal, even though I'm about to burn myself. Ouch. The crimp attaches the wire to the terminal. And I'm gonna do all 4 of them, and then I'm gonna stick them into the receptacle. If you don't have a crimping tool, try this. Take the wire, tin it, make sure it's not too long because you don't want it to hit the lever portion. Put it in place, and then crimp the first part over, and then crimp the second part over. Then holding it in place, just put a little solder, just a little solder on it. So yeah, that'll get you by. There's a small flap on the back of each terminal. That is what clicks it in place. If you don't hear it click in place, then you don't have it in all the way. So I always put the terminals on the wires first, and then I put them into the header. I like it when things click. It's like, oh, I did it right. Now, if you want to remove it for whatever reason, you could actually push down on that little flap. And you push down on the flap, that allows it to retract, and then you can pull it out. If you do it too many times though, you'll break the flap. So I only suggest doing it once or twice maximum. And then as far as the header goes, it's pretty straightforward. See how I'm holding it with my finger? Now I'm going to put some solder on one of the connections my finger isn't touching, for obvious reasons. Again, just enough to hold it in place. Then I'll do the rest. Bam, bam, bam. So this is good for a wire to board connector. And it's got the tab on it to keep it from being pulled out accidentally. You wouldn't have protection like that if you're just using a board to board connector with wire, which you can do. I've done it many times, but this is the proper way to do it. Felix, why are these crappy computers laying on the nice, clean table?
Well, aside from the fact that I'm gonna eat them for lunch, I brought these out here because they have examples of DSub connectors on them.
Oh yeah, DSub, or sub-miniature connectors, because this was considered small back in the 70s. DSub connectors all look like upside down trapezoids. So there's almost always just 2 rows of connectors, although with the VGA you had 3 rows, but this was a lot more common. And technically, I guess you could consider this a DSub as well because it has a frame around it. It sits in a panel and then a plug or a cord goes into it. So this is like a DSub, but it's kind of more advanced. So yeah, but typically the DSub has the same spacing of the pins. You see this also in old SCSI ports, parallel ports. Here's a DB15 from something. The nice thing about the DSub connectors is the pins are actually labeled, see that? So that's pretty handy. So if you find a data sheet like, oh, here's a VGA connector, here's an old RS-232 connector, you can be like, oh, there's the pin out they refer to, it's right there. So even though these were super small by Jimmy Carter standards, they had enough room for text, and that's nice. I wish every connector had numbers on it. DSubs are great for panel mount connections. In order to save my sanity, I'm going to attach the connections before I put it into the hole, otherwise I'll go crazy. Because if you put it in, see how the solder cups are above and below? If you put it in, you wouldn't be able to get into the lower solder cups. So I'm gonna do this. I'm gonna actually go up through the hole. So with these, put the wire into the solder cup. See how it fits in there? So that's handy. Kind of holds it there for us. Every time I win an Oscar, my salary spikes. There we go. Are people really gonna believe that someone can train raptors? They'll believe it if it's Chris Pratt. Okay, all the connectors are in place. Now I can fish it through. And then we can use screws and nuts to bolt it in place. And that's how you install a DSub connector. Let's talk about IC sockets next for dip package chips. So, you'll have an integrated circuit like this, and you can wire it directly to the board, but what if you fry the chip? What if you need to change something? What if you need to change the chip? So it's often useful to have a socket. So the sockets, they add a little bit more cost because you have to buy them, but they're handy because you can swap out the chips easily. If you look at older electronics, everything would be socketed. It was really easy to replace them. Or if you see only one thing socketed in an old piece of electronics, oh, that's a piece that's going to fail because it's socketed for our convenience. But when you're troubleshooting on perf board, sometimes things break or the magic smoke comes out.
Yeah.
And it's useful to be able to swap it out. So most dip sockets are going to be 0.1 inch or 2.54 millimeter pitch. So they'll fit into standard PCBs. Dip sockets are well worth the added cost for ease of use with your project. Let's go over some tips for installing them. We've used these sockets a lot on the show, but I've never really gone into detail on them, so I'll do that now. What I'd like to do is I like to put them in the PCB, and then I hold them like this, and then I solder them from the back. That way they stay as flat as possible. Otherwise, of course, they'll fall out, and you don't want that. There's a notch on the top of them, right there. That matches up to the notch on the chip. So make sure you orient them the way you're supposed to, because what if someone else comes along and puts the chip in backwards? That's not good. Okay, so I'm gonna hold the back of it in place and just get a little bit of solder here. And I just, get one corner, get another corner, and now it'll stay put. All right, I'm gonna do a couple of these right. So you basically flood it with solder until the solder surrounds the pin. I'm gonna try to do one of these wrong. There. See this one? It is technically connected to the pad, but there's a gap. So this is what you call a cold solder joint. You don't want that. Another thing is if you try to bring solder to it, And you're like, oh, I'm just gonna stick some solder on it. See that? See how it doesn't flow around the pin very well? Now that was fine to do the corners to hold it in place, but that's not what you want. So, the proper way to solder is to heat up the part and then bring the solder into it. So only bring solder to something with an iron if you absolutely have to. Because as you can see, it doesn't do a very good job because there's no new solder to flow into it. Then we're just gonna finish it up. Even if you don't need all of the pins, I usually solder them all anyway, just because it looks more consistent. And if you have to add it later, you don't have to worry about hitting wires or whatever else you've done. Oh no, I accidentally bridged two together. That's fine, just get your iron pulled away. There we go. When you're inserting chips, you usually wanna bend the pins slightly in toward each other, because usually a brand new chip won't fit perfectly into a socket. And then before you press it in, make sure that all of the pins are gonna go in. You don't want this to happen. Look at how terrible that is. But even worse is this. If the pin's too far in and you compress it, oh no. Oh, see that? We actually messed up the pin inside of it. See how it's pressed over too much, unlike the other ones? It'll still work, but it's not gonna work as well. So you want all these pins to be as level as possible. Again, with a new chip, that's not gonna be a big deal, but if it's something you've pulled onto something else, the pins probably won't be straight. Like this was probably removed from an existing piece of equipment. If there is some solder on the pins, what you wanna do is basically heat it up and pull it off. You don't necessarily get rid of it all, you'd have to make it consistent. Another thing I like to do with these connections is run a common ground and power. Upper right is gonna be power, lower left is gonna be ground, and like 95% of the time with these types of chips. So I'll usually run a power down this way and a ground down this way, especially if you've got multiple chips stacked up. As far as counting the pins is concerned, upper left, or where the notch is, sometimes there'll also be a circle or a marking right here. That's 1 all the way down to 20, or whatever number it is. Then you start up over here, 21, all the way up to the total count of 40. So you start here, end here.
All right, Mr. Heck, what do we have in this exhibit?
These are board-to-board headers and receptacles. So before we looked at everything, which is mostly wire to board or card edge to board, these are board to board. So you'd have one of these on one PCB and the other one on the other PCB, and then you can mate the PCBs together.
Well, what's so different from a card edge connector?
Well, a card edge connector, you basically have to have it at a right angle. So if your PCB is here, another card has to come at a right angle. Think about how much space a PC takes. Everything's at right angles, it eats up space. But with these, you can sandwich things together. So you can put one wherever you want on a board and then put a matching header on another board, and the boards are kept in the same plane. They're kept level to each other, like a sandwich. So these larger ones are obviously through hole. We use these a lot on the show. They're 2.54 pitch, standard, like a PCB. You can also get multiple types. These are surface mount. See how the pins flail out to the sides?
Yeah.
Yeah. So you can have even higher densities and lower profiles by using surface mount models. Yeah. So you could mate your boards even closer together, just like that. Let's look at some examples on how to use board-to-board headers for a project. Let's do a board-to-board connector example. I'm gonna take this receptacle here, break it in half. Not all of them break in half as easily as others. You can also use angle cutters to cut them apart. Another thing you can do is to actually remove a pin manually and then bite where the pin was using the angle cutters, and then you're just cutting through the plastic. All right, let's attach these headers onto this PCB. Now, one problem with this is these are single-sided copper clad, so we kind of are limited to our choices of where we put these, but you'll get the idea. But if this was a real PCB, we'd have pads on the top and the bottom. You can do the same as before, basically tin it, make sure it's straight, not crooked, then hit the other ones. And just like the dip socket, you want to make sure that the solder completely envelopes the pin. If it doesn't, add more solder. So by holding it with my finger, it keeps it from rocking because the bottom of it is flat, and therefore it will be straight when you solder it. I like to take the header, put it into the receptacle. Then you can just break off what you need, which is why I usually buy very long headers and then just break them down. See how we got that now? And we can sandwich it together. Just like before, we're gonna wanna make sure that we keep it straight, although it's easier now. So I'm bracing it on both sides with my fingers. One thing to watch out for when you're doing this is if you solder the receptacle second. So if I had this together and then I soldered the receptacle, there is a chance that the solder will wick down the pin on the receptacle and actually seize against the header, in which case it would be soldered together and you wouldn't be able to remove it. So it's usually a good idea to put the receptacle, the thing the pin goes into, in place first, and then put it together and then solder the header. So you see this a lot in PCBs. They'll make like daughter boards or they'll add on features by using headers. Board to board connectors. Felix, I see you brought out some ZIF connectors along with flat ribbon cables.
Yeah, they're really great for connecting small pitch to boards.
Okay. So this is a flat flex ribbon cable. You see this a lot in modern LCDs and electronics. It's mostly used for signaling. You can't carry a lot of current, although if they do want to power with it, they'll actually just have multiple pins carrying a signal. ZIF stands for Zero Insertion Force, which sounds like a Chuck Norris movie. And it's called that because you can put the connector in pretty easily, but then you have to usually clasp something to hold it in place, such as that piece of plastic there. And you want to take care when you're doing this that you don't break anything, so it is one negative of them. And you also want to take a look at the orientation. Like sometimes the pins will only be on the top or only be on the bottom. So your flat flex ribbon cable is only going to have pins on one side, so you want to make sure that you actually have it oriented correctly. Like in this case, you put it in, see there's no force to put it in, but then you have to usually use some tweezers or needle nose and squeeze this in place to lock it. One cool thing that you can do with the flat flex ribbon cable is turn it at right angles very easily and very flat. So if your circuit came out here, you can actually go whoop, bend it down and over. Yeah. The biggest thing to think about with these is how not to damage the cable or the connector when using them. Let's look at some examples. To release cables from ZIF sockets, there's usually two main ways to do it. You either pull tabs at the sides of the ZIF socket like this to release the cable, or sometimes you have to actually lift up the socket using a small blade or screwdriver. So you'd come in like this and then you'd twist slightly. See how it lifts up? If you're taking something apart and you haven't seen it before, you should probably, approach the ZIF sockets with caution. You don't want to ruin them. But if you do ruin them, there are ways to fix it. So let's say I ruined this socket and it was destroyed. Oh no, I've ruined it. It's doomed. Well, there are ways to hack it back together. In this case, I'm going to take a small piece of just clear plastic that I got from a product. It's probably from like a controller box or something. Cut it to length a little longer than it needs to be. Then I'm going to put the plastic in over it. Notice how there's pins on either side of the connector, the top, and there's also pins on the bottom. So basically it depends on where the connections are on your cable itself. So in this case, they're on the bottom. But the top and the bottom pins are the same connection. So I'm going to put the cable in first. And now I'm going to wedge in the piece of plastic over it. And that will push the cable down onto the pins and restore the connection that I damaged. So try not to break them, but if you do, that's how you can fix them. ZIF sockets. Take your time, examine how the hinges work, and remove and insert them properly. You can browse element14.com to find many more different types of connectors than we discussed in today's episode. Our goal was to talk about the most common connectors and how they can be used for your projects. That's all the time we have for today. Of course, you can go to element14.com/TBHS to learn about upcoming episodes, builds, and special events. We'll see you next time. Because back in the 80s, this was considered small. And the Academy Award for Best Performance opposite Chris Pratt goes to, it's amazing. It's on the cover of Byte magazine with Chris Pratt because it's a movie. Like we would say Kleenex or Twinkie. When in doubt, shoot it with a laser.
Well, I need my lunch.
Oh, I'm hungry. I'm gonna eat a laptop. No. You're gonna take a mega bite out of it. The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.